This is my first of many video homework assignments. We have a given set of numbers. I have to find the mean and the median of set numbers. So what you'll do is sort the data like so, and then you'll find the mean, which is basically adding all these numbers up for the sum, which is 1,706,000, and then you divide it by 2. That's how you find your mean, which will equal 24,500. That is my mean for this equation, for this data set. To find the median, you find the average of the fourth and the fifth values, because n equals 8, which is basically 154,000 plus 150,000 divided by 2 again, which is your total, will equal 147,500. And that's the median of this data set. Next question is state of measure better represents typical house price here, and explain why. The median will be 147,500. The median better represents a typical house price. Most homes are clustered at the 120K to 154K range. The median lands inside the cluster, while the mean is pulled far above from where most homes sit. That's explaining it. The effect, now, next question is explain how the outlier affects your answer. So if we explain, we're gonna look at the 800,000, basically, because the 800,000 outlier strongly inflates the mean of the 224,500, but barely moves the median from about 154,000 without it to 147,500 with it. This illustrates the mean is sensitive to extreme values, whereas the median is robust to them, especially in small data cities. That's basically the first problem, all figured out, all solved. Fairly simple in a sense. Next would be problem 2. Don't have the questions written. I have my laptop here. Can't see, so I can pull up the questions, so it'd be easier for me. But that's the data set, 55 to 95. First question is find the 5-number summary, the mean, Q1, median, and Q3, and the max. You probably can see my laptop now. It's like right there. But yeah. So again, data set is sorted. Kind of messed up a little bit right there, but it's fine. The minimum will be 55. That's the min. The median is the middle value of the 6th of the 11th or of the 11 numbers. So the median will be 70. Q1 will be the median of lower half, so 55, 60, 62, 65, and 68. So you find the middle of that number, which will be 62. So Q1, 62. Q3 is the same thing, but just on the other side. So that would be 72, 75, 80, 85, 95. And then find the middle of that number, which is 80. And then the maximum is the easiest one. Max is your 95. So your 95 will be your maximum. And then second question, complete the IQR and identify any suspected outliers using the 1.5 times IQR rule. So IQR basically is Q3 minus Q1 equals 80. Sorry about that. Minus 62 minus 18. Ooh, yeah. Wait, hold on. Yeah. I think I'm doing this right. I believe so. Not 100% sure. But hold on. Let me backtrack real quick. My bad. I'm looking through my notes. All right. So outlier fence. So the lower fence will be Q1 minus 1.5 times IQR, which will equal to, so let me write that down. So Q1 minus 1.5 times IQR, which will, when we fill this out, will be 62 minus 27 equals 35. Can you see that? Can you see that? Yeah, you can. All right, cool. Upper fence. So this is lower. Now we're doing upper. I can't spell today, apparently. Which is Q3 plus 1.5 times IQR. Once this is filled, it would be 80 plus 27 equals 107. So any data less than 35 or greater than 175 would be an outlier. None of the values fall outside these bounds. No, then so meaning there's no suspected outliers. The third question for this: draw a box plot based on your results and describe the shape skew. So basically, box plot, fairly simple to draw, but I don't have a number line, and I hardly doubt that I would write a number line all the way to 95. So when put into like my laptop, shown data plot, the box is at Q1, which would be at 62, and the Q3 would be at 80. The line of median will be 70 inside the box. Whiskers extend to minimum 55 and max of 95. There's no outliers plotted. The data is fairly symmetric around the median, slightly positive skew. The upper whiskers 70 to 95 is no longer than the lower whiskers of 55 to 70. And the maximum is farther than Q3 and than the minimum of Q1. Basically how it is. Problem 3. So problem 3. Package weights shipped by a company are approximately normal with mean of 12 pounds and standard deviation of 2 pounds. So what proportion of the package weighs between 10 to 14 pounds, which is question 1. If we look at my notes. So the formula you will be using will be Z equals X to U, and then standard. So for 10, it will be 10 minus 12 divided by 2, and that equals -1. For 14, it would be 14 minus 12 divided by 2, which equals positive 1. So we want P minus 1 less than or equal to Z less than or equal to 1 by the 6895, the 99.7 rule. About 68% of values fall within one standard deviation of the mean, which will be 68%, which is the answer for number 1. Number 2, question 2, what proportion weighs more than 16 pounds? We'll be using the same thing. Same type of like formula for this. Just gotta make sure this is recording. All right, cool. So for 16, we'll do Z equals 16 minus 12 divided by 2 equals 2. We want P and so Z be greater than 2 by the 95% rule. About 95% of the value lie within 2 standard divisions from 8 to 16. That means 5% are outside, split evenly 2.5 below 8 and 2.5 above 16. Hold on, sorry. So your answer will be 2.5%. Okay. And number 3, use and briefly justify the 68, 95, 99.7 rule for your answers. So 68% of values lie within one weird freaking O thing. Gives proportion between 10 and 14 pounds. 95%. 95% lie with 2. Leaving 5% outside and so above 16 pounds, which will equal to 2.5%. A normal curve sketch will show the bell shape centered at 12 with markers at 10, 12, 14, and 8 and 16. So total 68%, 2.5%. And then these come directly from 68, 95, 99.7 rule, describing the normal distribution of it. And the last one, problem 4. Still recording. Cool. Assume SAT math scores are normal with mean 500 and standard deviation of 100. First question is, find the score that marks the top 10% of students. So, to find, usually they gave us 500, they gave us a standard deviation, which is 100. To find Z such that P, Z is less than Z equals 0.90%, 90 from the standard normal table or calculator. So, yeah, convert back X to 0.90 equals 500. So let's do that. So X to 0.90 equals 500 plus 1.28, 16. Then you add 100 equals 500 plus 28.16 minus 628.16. So 90th percentile scores is about 628.2, which can be also shrinking down to just 628. Interpreting the integer SAT scores, the smallest integer score that reaches the top 10% is 629, since 628.16 is the continuous cutoff. So 629 is your 10%. Simple enough-ish. Question 2, find the score that makes the bottom 25% of students. So, sort of the same formula, just rearrange the numbers differently and look at the table, the Z table, which formula for that would be X 0.25 equals 500 plus parentheses negative 0.6745 parentheses, close parentheses to 100, close parentheses, minus 500 minus 67.45 minus 432.50. So it's the 25th percentile score is about 432.6. Or 433 to round up. So at an integer cutoff score is 432 or lower, fall into the bottom 25%. So that's your answer. Well, this is technically your answer, but that works too. Stop recording, show your work, convert to z-scores, use standard normal table or calculator, and transfer back to your original scores. So, top 10% cutoff, top 10% is 628.16. Bottom cutoff will be 25%, which will be 432.5. There you go. This concludes my first video homework for elementary statistics. Appreciate it.